In this video, we will continue the global BGP configuration in our network. eBGP will be configured between Customer Router 2 and XR Router 4 and XR Router 5. iBGP will be configured within ISP2. We will use AS number 2 for the customer, while AS number 67890 for ISP2. Point-to-point and loopback IP address are already pre-configured in Customer Router 2 and XR Router 4 and 5. The same task and objective with ISP1 will be configured in ISP2. Refer to the screen for the additional details and commands. Let us conduct basic verification and reachability test between ISP2 and Customer Router 2 before we proceed with the BGP configurations. Point-to-point ping tests are successful. We can now proceed with the configurations. Let us begin with the Customer Router. Here, the configuration is the same template with Customer Router 1 since they are both XE routers. Basic BGP configuration is done in Customer Router 2. Let us now proceed with XR Router 4 and 5. Here, the configuration template is different since we are dealing with Cisco XR routers, but the concept is the same with XE routers. Let us begin with XR Router 4 and configure eBGP first. Let us continue and proceed with XR Router 5. eBGP is already configured in XR Router 4 and 5 facing Customer Router 2. Let us verify the BGP neighborship status. In Customer Router 2, both BGP neighborships to XR Router 4 and XR Router 5 are established. The loopback 0 is also advertised in the global routing table. As we can see, BGP connections are already established. but the prefix that is advertised by CE Router 2 is not installed on the BGP table of XR Router 4 and 5. For XR routers to accept the routes, in our case from CE Router 2, we need to create a route policy to allow the prefixes both in XR Router 4 and 5 and apply inbound under the BGP address family. For now, the policy will accept any routes from the customer. No condition or any specific destination will be configured. Let us copy the policy in XR Router 4, then apply it to XR Router 5. Route policy has been applied both in XR Router 4 and 5 facing customer Router 2. Let us verify the BGP routing table on the PE routers. Both XR Router 4 and XR Router 5 now receive the prefix from customer Router 2. Let us proceed with iBGP configuration in ISP2. XR Router 1, 2, 4, and 5 are the PE routers, while XR3 router will be the P router or the route reflector. Begin with XR Router 4 and establish iBGP neighborship to XR Router 3 only. Before we proceed, make sure to configure Next Hop Self in XR Router 4 and XR Router 5 towards XR Router 3. Continue and proceed to XR Router 5. Establish iBGP neighborship towards XR Router 3 only. The same thing with XR Router 1 and XR Router 2. Establish iBGP neighborship towards XR Router 3, but no next hop self-configuration for now. After the PE routers, let us proceed and configure the P router or root reflector, which is XR Router 3. Configure root reflector client under the address family to all the PE routers. In XR Router 3, let us check if the prefix received and accepted from both XR Router 4 and XR Router 5. As we can see, the prefix advertised by customer router 2 is now received and installed on the routing table of all the routers in ISP2. ISP2 facing customer router 2 is done. We can now proceed with the eBGP configurations between ISP1 and ISP2. Next task, configure eBGP between ISP1 and ISP2. Customer router 1 must reach and receive the prefix advertised by customer router 2 and vice versa. XE router 4 must peer with XR router 1, while XE router 5 must peer with XR router 2. Point-to-point IP addresses between the routers are already configured. Refer to the network details on the screen. To achieve our task, upon configuration of eBGP between ISP1 and ISP2, we must configure next hop self on XE router 4 and 5 and XR router 1 and 2 towards their respective P or route reflector routers. Route policy, allowing routes must also be configured in XR router 1 and XR router 2 facing ISP1. Let us begin with XR router 1 and XR router 2. Configure eBGP, then apply route policy facing ISP1 and next hop self towards XR router 3. Apply the same configuration in XE Router 4 and XE Router 5. eBGP between ISP1 and ISP2 is done. Let us verify the BGP neighborship and routing table of the routers. Let us start with the routers within the service providers. All the routers in ISP1 and ISP2 are now receiving the routes from Customer Router 1 and Customer Router 2. Let us check the routing table of the customer routers. We can see from the result that to reach each other, they have two choices of path. With the default attributes, the best path is using the route with lower router ID. Both customer routers can now receive and reach each other. In the next videos, I will show and configure BGP attributes to manipulate the path of each customer's traffic. I hope that this is informative to you and thank you for watching.